I'm really thrilled to be here. It's my first time to Africa. I've been thinking about this for quite some time. So what I'm going to share with you is probably going to start with Stacy's discussion this morning. And that is, I was thinking about what I want to be when I grow up. And as I reflected on that, one of the things that it struck me is that every job I've ever had has been focused on digitization. And I thought it through and realized that the root of it goes to my experience in college. And the experience that I had, I'm old enough now that when I was in college, when I would register for classes, there would be very long queues that we would go through for days at a time. And when we would wait, you'd get to the end of those queue, and by the end of it, you would realize that class had filled up, and now we have this crappier alternative class that you can take. It'll give you your credits, but it won't be very interesting. And then one year I went back, and there was just a terminal there. And I went up to the terminal, and I entered the classes that I wanted, and sure enough, I got exactly what I wanted. And it was a knockout experience. And what it made me realize is that there's things that humans are good at, and there's things that computers are good at. And we'd found a way to really let the computers do what they do best. And for me, it was the first experience with digitization, and it kind of set the template for the rest of my career. So I look back now on 25 years of experience working with companies, working through digitization. It started with working in back office processes, miserable work, worked on automating that in the retail industry, worked in Honeywell for a while in the avionics industry, trying to figure out how to digitize the cockpit of an airplane to move away from traditional big folded maps. And then ultimately I joined HP, and the first job I had with HP was building a new business. And that business we built up to be focused on taking our Inkjet technology and drive it into use for high volume print manufacturing, but digitally defined. And the idea was that you would move from analog production processes where you make many copies of the same thing over and over to digital production processes. And I spent 8-9 years learning how to sell that. And really what happened was we weren't selling that. What we were doing was helping companies learn how to transform their business to take advantage of the benefits this new technology had to offer. So that's going to be a theme that's going to run through everything we talk through today. So we talk in HP a lot about the fourth industrial revolution. There's been lots of different definitions of this, but in the end, you know, there have been a succession of waves of technology that have changed the human situation and also changed the balance of market power. First industrial revolution with the power of steam and water, England was able to move from cottage industry to true industry. With the advent of electricity and specialization, the U.S. moved into a situation of prominence with Ford and mass production. And more recently in Asia, what we've seen is with IT and logistics, the ability to have a very widely distributed logistics and supply chains. But with this next industrial revolution, what we have is the opportunity to have something that involves data, involves connectedness, and as a result of that, I think it has profound implications in terms of true ability to participate globally in the new economy. So, as we look at all of this, we talk a lot in terms of industrial revolutions about, you know, government, society, and things like that, but in the end, it really comes down to people. We see a lot of things that, you know, affect us personally, which come down to personalization, localization, customization, and all of these things change the way we interact. There's a lot of benefits, but in the end, they're really human benefits. So these trends affect all of us, and one of the things that I do is work on the World Economic Forum. And in the World Economic Forum, there's an initiative called Shaping the Future of Production. And the idea is to take a very inclusive approach, a holistic approach, and look at the impacts that we can have in a positive way for how things play out with this new generation of technologies. And one of the things that the World Economic Forum has assessed is that within the next 10 years, the value that will be created by these technologies will be on the order of $100 trillion, which is a hard number for me to get my head around. But what was even more striking is that they say that 60% of that will be value that accrues to society rather than just corporations. And at first I had a hard time relating to, what does that mean? So I'll make it personal. What you see up here is just a bunch of applications that we do with 3D printing. And actually, sorry, now you'll see it. These are a bunch of applications with 3D printing. And one of them is highlighted, and it's one that's near and dear to me. I've been a marathon runner for many years, but I started running into issues as I aged with repetitive stress injuries and things like that. And what you see circled up there is orthotics. Now, orthotics is not new, but what was new is the fact that I could go and get my feet analyzed. I could get my gait analyzed as I walked or as I ran, and then I could get a set of 3D orthotics that were completely personalized to me, that completely changed the mechanics of how I run. And what that did is it made it possible for me to be able to run, and I went from running marathons to running a few kilometers to running marathons again. And for those of us that are runners in the audience, running is everything, and so that was priceless. Another example, and this one is really cool. Pardon me. So medical modeling is something that's not new. People have been doing it for a long time. And the imaging that you get in the medical space is some of the best imaging that exists in the world, some of the best data sources in the world. And we've been working with hospitals to use the technology for doing medical modeling in 3 dimensions. And at first, my thought was with, AR, VR, all these kind of things, visualization technologies, those would be the things that people would focus on. But in fact, what we found is that having a tangible, 3-dimensional model is really critical for planning very complex surgeries. And this one is an example of a child with a complex heart defect. So we work with the Mayo Clinic, and they've shared with us some of the examples of this. And there was one that really struck with me. And that was that there was somebody who had a tumor on the right side, and that tumor was in a very awkward location. And generally what that would have meant is that they would have had to do the surgery from behind. It would have been a very invasive surgery, and it would have been something that took a long time to recover from, and it probably would have left a lot of collateral damage. And what they were able to do is take this model, work with the team, and find a very unique approach to getting to that tumor. And by virtue of that, they were able to do it through a keyhole incision through the front. And I mean, the implications of that in terms of just scarring, in terms of time to recovery, in terms of the medical process, how long that surgery took, huge impacts. And they have story after story after story like this. So that, again, is a benefit that accrues to society that's far more than just a commercial outcome. This next one is going to be interactive. So everybody get your mobile phone. This is one of my favorite stories. And what it's going to require is that you either type in nice-to-meet-you-hp.com, or if you open up your application and you look under social, it should be at the top and it should be a link you can click. Now, for just this section, I'm not going to be offended if you're looking at your phone. And what I wanted to share with you was a company that we work with. And what's unique and what I would want you to internalize about this is that this was a tiny company in Ostrava in the Czech Republic. And what happened is, came to a show like this one in New York City. And when they got to the show, it turns out they had come because they wanted to meet and talk with us about how this technology could be applied. And they had profound ways of using this technology. And they came to the show and it was great and it was packed. And I mean, there were people lined up against the back. And when the show was completed, they thought they would just come up And then what ended up happening is that we kind of got rushed in the stage. Now that wasn't because of me, it was because we had a bunch of 3D printed parts laid out and everybody wanted to kind of see and so forth. And so they were perplexed. They said, we've flown all the way to New York. How are we going to get their attention? And what you see on that is a website they put up to get our attention. And let me tell you, they got our attention. This went completely viral within HP, up to the CEO level. And we said, we have to go meet with these people. And it's some of the most inspiring people that I've ever had the chance to work with. CEO of the company, the short story, the CEO was driving at 2 o'clock in the morning one night and somebody had read about HP's new 3D printing technology and said, you've got to take a look at this. He was just about to buy some other technology and said, no, forget it, I'm not gonna. 3 o'clock in the morning, he gets home, he takes a look at it, and that was something that he said, we've got to go find out about this. And so he came, but we had a hard time connecting. But we've solved that. So from what you see there, them reaching out to us, this is where we are now.
So this helmet is indicated for patients with craniosynostosis after operation via endoscopic control, and is necessary part of the treatment for this baby.
With MultiJet Fusion technology, we are able to design and print out directly the final product. The process is faster and the product is lighter and more comfortable.
3D printed helmet helps us to use a minimal invasive technique for treatment.
With 3D printing by HP, we can disrupt the whole industry by providing patients all around the globe with new advanced products that can improve their lives.
So they're now working with us. Thank you. Thank them. They're now working with us, and we've been able to work together collaboratively and jointly share each other's work around the world. And they're, providing services. And they've built this awesome little ecosystem in Ostrava, taking advantage of local government, educational facilities, and now they're really just blooming. So anyway, a really great story, great group of folks. So you can see a lot of these kind of medical things and how they accrue benefits to society. But for 3D printing, it goes farther than that. There's huge benefits that are possible for the environment. And the way you can think about this is that when you're 3D printing something, you build up layer by layer, and you only use the material that you need to make that part. There might be a little other stuff for a support. But traditional processes are more that you're milling and molding and cutting things down. In the aerospace industry, they have a term called buy-to-fly ratio. Has anybody ever heard of that? Any show of hands? Not a lot, okay. Buy-to-fly ratio is a very important term for the folks in the aerospace industry because it says I have to buy, a certain amount of something to be able to get to one part that I can fly. What is that ratio? And those ratios, if we had more time, we'd do a little, guessing on what that might be. It starts around 10 to 1, but it grows up to 100 to 1. I have to buy 100 of something, 100 pounds of something to get to one part to fly. It's very inefficient, but that's just material. If you think about the ability to 3D print in remote locations, only where you need it, then the other thing that you can look at is the reduction in logistics. If you look at lightweighting and taking mass out of materials, again, lots of opportunity to take out cost and ultimately reduce the carbon impact. And when I talk about stuff like this, I try to keep it from being ethereal and try to make it real. So in a second, we're going to look at a very specific case. For 3D printing, the things that, we would want you to think about is it's a very flexible technology, right? So you can have one machine that is producing parts for the automotive industry, for the aerospace industry, for healthcare, for consumer goods, and it's one piece of capital. The other thing is you're not making molds and tools and things like that that just make one thing. It can make lots of different things with that one piece of capital. You can then have, it's scaling out and then have distributed production rather than highly centralized production. The thing that this does is that it gives you freedom. If you think about the design process, if you're not milling, molding, and have all of those constraints, then you have a lot more design freedom, profoundly more design freedom. And then at the same time, you don't have these really high costs or barriers to entry to start using the technology for production. That means it's going to foster entrepreneurship. So let's look at an example and make it a little more real. This is my favorite part. It is about the most mundane part you could imagine. But what it's used for is we have large format printers in HP that print things sometimes just for like the signs you see in the back. Very large format. And so it has a scanning axis that prints back and forth. And that part sits on that scanning axis and holds a sensor. And for those machines, we don't sell millions of these machines a year. We sell, tens of thousands or thousands. And by virtue of that, the right way to do it historically has been out of machined aluminum. And so you can see with the machined aluminum, you can see what the weight is and what the structure looks like. But that had to be cut down from a bigger block. We were then able to say, we can 3D print this. And by virtue of that, we can move from metal to plastic. Not a massive jump in terms of engineering feats. But it really made a big difference in the material weight. So the engineers looked at that and they said, well, okay, but we could take it a few steps further and start reducing the mass of that part. And then it got really interesting because at that point, the design engineers started working with the manufacturing engineers. And the manufacturing engineers are the ones that are always optimizing for design for serviceability, design for cost, et cetera. And they got working together and started collaborating, and out of that, they worked on algorithms that highly optimize those parts. And what you see on the far right is something that does not look like something I would make or a human would make. And again, it goes back to letting computers do what computers do best. They run simulations really well. And so what you see is one single part, half the cost, an order of magnitude reduction in the mass or the weight of the part, and then 2 orders of magnitude reduction in carbon footprint on that one part. So as these examples started coming up inside of HP, we quickly realized we need to understand the potential impact of this technology. This may be huge. We want it to be huge, but we need to dig in and start working. And so we started working on a product which was our next generation of 3D printer. And this machine, we were able to conceive from the very beginning, having learned a bit about how to design for additive. And design for additive is a big word in HP now because there's a profound difference in how you design for the way things have always been done versus how it will be done for this technology. And what happened was we had the engineers work together between design engineering and manufacturing engineering. And in the beginning, they said, it makes sense that there's maybe 12 to 24 parts that we should 3D print because it's cost effective or it brings a performance improvement. The rule we had is we're not going to do this just to say we 3D printed. We're only doing this because it's a better business outcome. And what happened is the engineers worked together and drove it so that the number of parts on this one machine is over 140. Now, for those that don't have much exposure, that may not seem like a lot. To the best of our understanding and knowledge today, there's no other machine in the world that has more than 140 3D printed parts in that machine. And so our engineers are now working on the absolute cutting edge of driving this technology. And now what we're doing is taking what we're learning inside of HP and we're taking it out to work with companies to help them understand the impacts that this can have broadly across their company. So it's something that's really taking off inside of HP. And what I want to give you a sense of now is what's the powerful engine behind this? Why is it that we're able to get these kind of outcomes with our technology? And we're going to start speeding up a little bit here. So over the last couple of days, a lot of examples of Moore's Law. And as it works out, the mechanism for us for imaging, for 3D printing, is actually our Inkjet technology. So what we do is over a bed of material, we take our Inkjet technology and use that as a mechanism in one sweep to image an entire area for where we want the parts to be defined. And by virtue of that, we're able to take advantage of a technology that we've been investing in and developing for more than 30 years. And what you can see is that the performance of our 3D or inkjet printing technology has been accelerating at an exponential rate. And that continues today. And the reason for that is because we actually use silicon wafers as part of the MEMS technology for the printhead technology. So, you know, the dynamic with logs change. This is 30 years of investment that we're getting to stand on the shoulders of as we drive it now into 3D printing and additive manufacturing. And what that has done for us is it made it possible for us to create this first generation of 3D printing technology. And what I want to give you a sense of now, people were talking about earlier, things are changing faster than you might think. So this was our first machine. We brought it out in 2017. We had developed the technology very rapidly and developed the technology and the machine at the same time. And then we brought that product out. This is this year. This is this year. And what you see is we've already filled a full portfolio. So we have two, different variants. One platform, we have a new platform that will be for color 3D printing, and then another platform for metal 3D printing. And we did all of that in 1 year. And on top of that, there's something very important that I want to point out. We're taking an open approach. To drive this technology to be adopted broadly, we recognize that the material science behind this is going to be profound. There's going to be a lot of work required. And we could try to do all that ourselves. And in HP, we take great pride in our ability in terms of material science. But we have to think, how do you scale in a much more exponential way? So we decided we're going to take an open approach to materials. And we're going to get all the biggest materials companies in the world to work with us. And so you can kind of think of those machines as, your mobile phone, and the materials that are being developed for it as applications. And that's how we really want to drive growth with this platform. So what I want to do now is share, you hear fast adoption inside the company. You hear how quickly we're proliferating a portfolio of products with a lot of different capabilities. What I want you to hear now is the voice of the customer in how they're going through the process of looking at this technology and adopting it.
So 3D printing is not a new technology. It has been a technology that's been around since the late 1980s, and so it's not new. But what is new is the ability to do mass production in 3D printing.
We are an additive manufacturing-focused service company. We do work for any company, any industry, any vertical that you could think of. Traditionally, we've been a prototyping company, and with the introduction of this HP equipment into the market, we've been able to actually get into full production runs with this new technology.
So our growth has been significant with the HP MultiJet Fusion technology. The main industries that are really driving it are the healthcare side, the aerospace side, and industrial products. There are new products that could not exist without this technology.
We brought on our first 2 MJF machines in the third quarter of 2017. It wasn't too far into the first quarter where we were running our first 12 machines that we had a demand and needed 6 more. We plugged in 18. The day that they were plugged in, that equipment was full.
We are today now up to 24 machines with 72 build units running 3 shifts 24/7, and we expect that to continue to grow.
What has turned a corner for us is the throughput. The fact that we can push so many parts so quickly through this equipment and at a cost never before seen has really been the game changer. What we're doing today and what we've been able to do this year, inside of September here, we will produce 1.5 million parts through our MJF lab. This is new territory.
We have entered the era of digital manufacturing. It's happening. So if a company is not doing it, they're behind on the curve already. And we want to continue leading in this space.
Digital manufacturing is here, and Forecast 3D and HP are leading the way.
So the interesting thing about that company is they're not a huge company by any stretch, but they are at the absolute forefront of driving digital manufacturing. We're finding broad adoption across a bunch of different industries that you can see here. And that demand is really something that's just gaining steam like a locomotive. And we have not just one customer like that, but we have numerous customers like that across different market sectors. So again, my sense was to try to give you a sense of how fast this is changing and evolving. So making this, bringing this back to the local consideration, the question is, could this be a leapfrog technology? And I guess the way I would look at it is there is an existing manufacturing base. This is a technology that could augment that. It has certain capabilities and strengths that could be beneficial as well. At the same time, I do believe that it can be a leapfrog technology for moving into new market sectors that really haven't been served. It can also provide benefits like, building a population of people that are really strong in design and be able to support people that need it around the world. In fact, it's beneficial if people don't have long history of designing because they're not burdened by the understanding of how to design for older technologies. But there's also the ability to make things local, to do production locally in a very distributed kind of way. So across Africa, we're seeing seeds of emerging technology. Examples include renewable energy in a very distributed way, dams being put in place, renewable energy instead of coal. But I think the opportunity to drive change at grand scale is uniquely prominent in South Africa. New leadership, economic optimism, renewed standing in the international community, all of this makes for a fertile environment for investment and reinvention. And I'm sure that there's leaders in this room that are thinking a lot about how to prepare for this next industrial revolution and how to position for it. For us, what we look at are 6 keys. We have a role in this, the market has a role in this. As I mentioned, we're working very hard on bringing the product capabilities, bringing the material capabilities, but at the same time, the market has to be prepared to take advantage with design capabilities. New supply chains based on digital supply networks need to be implemented, and standards and policies need to be put in place that are supportive of these new technologies, that don't inhibit the adoption of them. So, for me, the call to action, we've learned inside of HP something that I think applies broadly, and that is that what really worked in terms of driving adoption of a new technology is a top-down mandate, supported by support from below for people who need to understand the details, how to use the technology, where to use the technology, how is it applied. And I think it's going to take a lot more than just digital factories. It's really going to take private sector working with the public sector to drive and sustain change of this magnitude. In addition, deep investment in education for future tech, upskilling, things that you've been hearing over the last couple of days, applied research to unlock the new applications, new regulations, adapted standards, economic systems, and incentives and physical infrastructure. All of these things are necessary, but the opportunity is there. So, as I said, the fourth industrial revolution is a human revolution. We have to be deliberate. 3D printing can bring unique and profound benefits, and it's accelerating quickly. So, in any event, this is from our front door. This is HP in Palo Alto. In Silicon Valley, from our front door to your front door, we look forward to collaborating with you and forging the new frontier with these new technologies. Thank you very much for your time.